Hi everyone. Today's lesson is 3.5, Understanding Slope-Intercept Form. I'm going to try and present to you just a brief lesson so that you can watch it over and over if there's something you don't understand. And anyway, let's give it a go. All right, so first of all, let's talk about the word slope. All right, there are other words we can use for the word slope. It's called the constant, it's called the rate of change, and it's also called unit rate. Okay, so I can use any one of these four words, and make sure you all know that it all means the same thing, the slope. In this chapter, we've been working on linear equations, equations that form a straight line when we graph them. So when we talk about slope, we're trying to figure out how steep that line is, whether it's going up, it's going down, if it's flat. So that's what we're talking about when we talk about slope. Most of the time we talk about slope as a ratio. It's a ratio of the rise over the run, and that's how we say it. It's the rise over the run. Okay? Now, in order to find the slope of a line, how steep it might be, we can use a formula for slope. Now, the letter we use for slope is m. M is always the slope for linear equations. And here's our formula. It's called y number 2 minus y number 1 over x number 2 minus x number 1. You can use this formula always to find the slope of a line. Okay, so let's see here. Now there are many different ways you can see slope. There's actually 4, so let's go over these 4 different ways. All right, so slope can either be positive or it can be negative. Now notice in this graph over here, this one that is a positive graph, my line is heading in an upward direction from left to right. And if you even take your arms and you try to mimic this like you're doing like an airplane, if your right hand is up in the air, that means the slope is a positive graph. Okay, and also I'll show you it's the rise over the run. I'll just do a different color here. This is going rising up and running over. That's a positive graph. The negative graph over here, this is my negative graph. Negative graph is a line that is going in a downward direction from left to right. Again, if you were to stand there and mimic the line with your arms straight out, if your right arm is lower than your left arm, then this line is heading downward. And again, it has a negative rise over a run. We're not really rising, we're actually going down. So this is a negative graph, running over. All right, so those are two types of graphs, the positive and the negative. You can also have these types of graphs. You can have a graph that is a zero graph, which means the slope is 0. It's completely flat. That is a horizontal graph, and we have gone over equations that look like this. These equations always say y equals and then some value here. And the fourth type of graph is called an undefined graph. Notice that this graph is vertical. It goes up and down. And we know that our vertical graphs are the ones that say x equals some value. Notice that this graph only crosses the x-axis. It does not cross the y-axis at all. It's just completely up and down. Okay, so those are our 4 types of graphs. And now we're going to practice using the formula to find the slope. Here we go, finding slope. All right. If you want to go along with me, that would be great. Otherwise, you can just watch. So in finding slope, we're going to use the formula method. In this method, here's what you do. You just need to pick any 2 ordered pairs. It doesn't matter which ones, just pick 2. And make sure you understand which one is the x1, y1 and the x2, y2. Once we're done doing the math, which is straightforward subtraction, always simplify your fraction if necessary. Okay, always simplify. All right, here we go. Problem number, let's just call it A actually. So I've given you this first set of ordered pairs. Here are 2 ordered pairs, and let's find the slope of the line that travels through them. All right, so I've labeled them for you. This is my first set of xy, and so I labeled them my 1s. This is my second set of xy, so I labeled them my 2s. And I'm going to use the formula, and the formula looks like this. y2 minus y1 over x number 2 minus x number 1. And so when I do the math on these, I get 3 over, this is -1, double negative makes a positive. This is 3 over 2. Now since my fraction is a positive fraction, you would say this is a positive slope. That means this line is heading upward, the line that travels through those two ordered pairs. This line is going upward. All right, B. Again, we have two ordered pairs. I'm going to use my formula. y2 minus y1 over x2 minus x1. Okay, in this one we have 3 over 0. And right here, you are never allowed to have 0 as your denominator. So this makes this problem undefined. And if it's undefined, we have to think back to the 4 pictures I showed you before. An undefined graph looks like this. It is a vertical graph going up and down. Letter C. Okay, here's two ordered pairs. Let's find the slope of the line that goes through these. y2 minus y1 over x2 minus x1. That's going to give us 0 over 1. And it's okay to have 0 as the numerator. That is fine. So, but the answer on this one, 0 divided by 1, is always going to be 0. This is called a zero slope. And if we think back to our 4 pictures, anything that has a zero slope would be a horizontal line that looks like this. If I'm trying to imagine what that line looks like, it's a flat line. All right, D. Let's find the slope of the line that goes through these two ordered pairs. So again, I'm going to go y2 minus y1 over x2 minus x1. I have 2 over negative 1. And if I do my math correctly, I'm going to go ahead and float the negative to the top. So this is going to say negative 2 over 1, and that's my slope of the line. Since it's a negative fraction, then I know this line is heading in a downward direction. It's a negative slope. Okay, so those are our sample problems so far on how to find slope when I give you ordered pairs, when you're given ordered pairs. But you're not always going to be given ordered pairs. Sometimes I'm going to give you a table of values, and those are just ordered pairs that are organized. So let's go ahead and pick 2 ordered pairs, and it doesn't matter which 2 you pick. So for example, I'm going to prove it to you. I'm going to pick this ordered pair 3, 6, and I'm going to pick the second ordered pair 4, 7. Let's do the math here. But then I'm also going to pick maybe the first ordered pair 3, 6, and I'll pick the last ordered pair 7, 10. It doesn't matter which 2 you pick. The slope will always be the same. So let's see, I'll do these first. 7 minus 6 over 4 minus 3. The slope of this one is 1 over 1, which simplifies to a 1. This is a positive slope. It's heading upward. Now if I do this one over here, it's going to be exactly the same. It's 10 minus 6 over 7 minus 3, which is 4 over 4. Again, it's 1 over 1. So again, it doesn't matter what 2 ordered pairs you pick, just pick 2. Okay, so let's go to the next one, F. Here's a table of values. It's just written in a vertical format. Again, I've given you 3 ordered pairs. Let's pick 2. Now, I'm not going to shy away from the negatives, so I'm going to pick the first one, negative 4, 9, and I'll pick the second one, 3, negative 5. Okay, so here we go. We're going to go negative 5 minus 9. That's y2 minus y1. And then I'm going to go 3 minus negative 4. My answer on this one, a negative 5 minus 9 is negative 14. On the bottom we have a double negative, which really makes it a positive, so I'm going to switch it to a positive 7, and I'm going to simplify. Negative 14 over 7 becomes negative 2 over 1, or the slope is negative 2, but if I want to write it like a rise over run, I'll keep it a ratio, negative 2 over 1. This line is heading downward. It is negative because my final answer was negative. Now, so far I've shown you how to find the slope of ordered pairs, the slope in a table of values, but what if I just give you a graph of a line? This is a linear function. It is a straight line, and I say, what is the slope of the line? Well, first of all, I can look at the line and go, okay, that line is heading upwards. I know my answer is positive. If I get a negative answer, I know I'm wrong. So here's my 2 ordered pairs, and it doesn't matter what order we write them down. So for example, I'll write one over here. So I'm going to write 3, 3, 2, 1 over here. But then some of you guys might want to write it down as, let's do 2, 1 and then 3, 3. It doesn't matter what order you write them either. Just write them down and do the math accurately. So let's just see, I'll go through both of these. 1 minus 3 over 2 minus 3. That's going to give me negative 2 over negative 1. But a negative over a negative turns both of these positive. So my slope is 2 over 1. And that's good, it is positive. So let's check this one. What if I wrote it down this order? This is 3 minus 1 over 3 minus 2. And when I do the math, I get 2 over 1. Either way, the answer is 2 over 1. Okay, so in this opening section here in this video lesson, we've talked about how do you find the slope given two ordered pairs, the slope if I write it in a table of values, the slope if I draw you a graph. It's always using the formula. That will be very helpful. Okay, so let's see here. Let's add on the y-intercept. Now the slope and the y-intercept go together. Once you know both of those, we can write the equation of a line. But right now we're just going to identify which is the slope and which is the y-intercept. And I'm just going to give you an equation. And you're going to identify those 2 points. All right, so here we go. If the equation is written in this format, y equals mx plus b, which is called slope-intercept form, the name slope is in it and the name intercept is in it. It's right here. It's the m and the b. M is the slope, b is the y-intercept. So on this first equation, y equals 2/3 x plus 5, I can say the slope, which is sitting right there in that spot where the m is 2/3, and the y-intercept, the b, is 5. Now I know this line is heading upward because the slope is positive. This is a positive fraction. It's heading upward, and I know exactly where this slope crosses the y-intercept. It crosses at positive 5, right here, positive 5. In question number 2, y equals negative 3x minus 2. My slope is sitting right here in this spot right there. It's in perfect slope-intercept form. It's negative 3 over 1. And my y-intercept is negative 2. This slope I know is heading downward. The slope is negative, my line must be going downward, and I know exactly where it crosses the y-axis. Crosses the y-axis at negative 2. Question 3, y equals 4. Now we've done these before. This is technically a standard form equation, but this to me says this line that I'm looking at is going to cross the y-axis at number 4. So if I just do a little visual sketch of this, and I say this line crosses the y-axis at number 4, here's the y-axis going up and down, so 1, 2, 3, it crosses just like that. So I can say the slope of this line is a 0 slope. This is a 0 slope. And the y-intercept, the b, the place that this line crosses the y-axis, is right here at 4. My slope is 0 and my y-intercept is 4. One more of these. Now technically this is also in standard form, but we've talked about these before. I can imagine that if I had a graph and I say to myself this line, when I graph it, it's going to cross the x-axis at number 3. So here's the x-axis and I'm going to go 1, 2, and it crosses right here. So I can see now that my slope is undefined. And if I look to see what the y-intercept is, I notice that there is no y-intercept. This line will never cross the y-axis. It'll only run parallel to it. So there is no b in this particular equation. All right, in problem number 5, we just got through practicing how to change a standard form equation into a slope-intercept form equation. That way you can determine for me the slope and the y-intercept. All right, so let's go ahead and do this now. We have 2x plus 3y equals 6. I'm going to take away 2x on both sides. That's going to leave me with 3y equals negative 2x plus 6. And now let's solve literally for y, so let's divide everything by 3. And my new equation, written in slope-intercept form, will be y equals negative 2 over 3x plus 2. Now I can look at that equation and I can see that the slope is sitting right here and the y-intercept is sitting right there. So my m is -2/3. I know this line is heading downward in a negative direction, and I know where this line crosses the y-axis. It crosses at +2. All right, so what we've just got through practicing is finding the slope given ordered pairs. We found